Hello, and welcome to Chapter 3, where we're going to be discussing the concept of stoichiometry. Now, this is a long word, but what it means in chemistry is understanding the ratios of products and reactants in a chemical reaction. Products and reactants in a chemical reaction. And this will be a very important concept throughout your journey in chemistry, which is why we cover it pretty early in our class here. And what this ultimately comes down to is being able to link the idea of thinking about individual atoms and molecules, or groups of them, or large numbers of them, and the masses that we can actually weigh using, say, a balance or something like that. So a lot of this chapter will be about relating a mass of a chemical to the number of particles that it contains. And when I say particle here, that means either atoms or molecules or formula units if we're talking about ionic compounds. So the important idea we're going to start with in this first video about stoichiometry is one of the fundamental ideas in chemistry, which is the idea of a mole. Now, this has nothing to do with the animal mole. I'm not sure why this word is what was chosen to refer to this, but a mole is a number, a number of particles. So specifically, 1 mole is equal to 6.022, and there's some more significant figures if we want to include them, times 10 raised to the power of 23 particles. Well, it can be 6.022 times 10 to 23 of anything. It's just generally we're talking about very, very small things when we're in chemistry and using moles. But you could have a mole of something else. In class, I'll talk to you about a fun comic where somebody goes, what if we had a mole of the animal moles? What would happen? And it's pretty interesting. So anyway, the idea of a mole is it's just a number. You could think of a mole as kind of being like 1 dozen. Right, 1 dozen, which just means you have 12 of something. Same idea. So we could have a dozen eggs, or a dozen pieces of bread, or a dozen pins, or a dozen people. Right, a dozen can apply to any type of thing. The same thing with a mole. A mole can be a mole of 1 mole of water, or a mole of gold or silver or anything like that. Now, we need to use a very, very big number because atoms and molecules are very, 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 very small. And you can see, right, this exponent here, 10 to the 23, means that this has, if we didn't have all the significant figures, this would be 6 with 23 zeros after it. This is a mind-bogglingly big number. But it's a number we use because it's actually a macroscopic quantity of a substance. So I like there's a picture in your textbook that I'm going to pull over here. Give me just a second. That shows what does a mole of stuff look like. And so this is a picture in your textbook that shows, let me just make the full screen again, where we have a mole. This is 1 mole of helium, which is equal to about 4 grams. Over here, we have 1 mole of copper. Let me make sure I have the right substances here. We've got 1 mole of iron in this spot here, 1 mole of sulfur, and 1 mole of mercury, which you don't want to be around a whole mole of mercury, right? And we can see that these are, a mole where we have this many number of atoms. These are all elements that we're looking at here. It's something that you can actually hold in your hands. And so it's relatively easy to weigh out a mole of a particular substance. So in the next video, we'll talk about how we can relate moles and masses and grams. So, how do I know that 1 mole of helium is about 4 grams? We'll talk about that in the next video.